Here's our first question. Describe and explain the electrical conductivity of sodium oxide, Na2O, and sodium in their solid and molten states. And then we've got that little pencil symbol, and it says in your answer you should use appropriate technical terms spelled correctly. So there's quite a lot to unpick in this question in just those two short sentences. So we'll start with the command words. There are two command words for this question: describe and explain. This is a 5-mark question. Unlikely to be more than 1, possibly 2 marks for describe, so the bulk of the marks are going to be in the explanation, but obviously the explanation is going to be very difficult if you haven't got the describe bit correct. Once we move on from the command words, what is the key information in the question? Well, it's asking us to do a number of things. It's focused in on electrical conductivity, and we are looking at two compounds, well, two substances. We're looking at sodium oxide there and sodium. And then the last bit, which is easy to miss, is it's asking about the solid and the molten states. So there's quite a lot in here just from that one sentence. So we need to think carefully about how we're going to structure our answer. In terms of linking it back to what we know about, this is a bonding and structure type question. We need to explain the electrical conductivity in terms of the bonding and the structure of the two substances. So let's start with the sodium oxide. Sodium a metal, oxygen a non-metal, so that's a non-metal and a metal, that's an ionic compound, so make a note of that. Its structure will be a giant ionic lattice, and sodium is obviously a metal, so its structure will be a giant metallic lattice. The sodium oxide will have ionic bonds and the sodium will have metallic bonds. Finally, in terms of how we structure our answer, I think here I'm going to treat those two substances separately. So first of all, I'm going to talk about sodium oxide and talk about the electrical conductivity of both solid and liquid sodium oxide, and then I'm going to do exactly the same thing for sodium, but I'm not going to try and mix the two of them up. So how do we go about this? So let's have a look. I'm going to start with sodium oxide. Sodium oxide conducts electricity as a liquid, but not as a solid. Start with a very simple statement. That's the describe bit done. Now I have to explain. That is because it is a giant ionic lattice structure . So when molten, the ions are free to move and carry charge. I've only really explained there why it conducts as liquid, and it's important that I go on and talk about why it can't conduct as a solid. So, however, as a solid, the ions are held in a fixed lattice and so can't move. So that's pretty much covered everything I want to say about the sodium oxide. Move on now to the sodium. Same sort of structure. So sodium conducts as both a solid and a liquid. So I've covered both states. This is because it is a giant metallic lattice which contains delocalized, careful to spell that right, electrons which can move and carry the charge. And there we go. That's it. Nice and simple. Talk about one, then talk about the other. I've only talked about electrical conductivity. Sometimes it's tempting to show what else you know. So you might think, well, I know a lot about the melting points of ionic compounds and metallic compounds, and you may well do, but that's not what this question is about, so there's no point wasting your time talking about it. The level of detail is important. To get all 5 marks, you do have to talk about in detail why the ionic compound will conduct as a liquid but not as a solid, and why the metallic compound will conduct as both. And then the technical terms here that we need to use: giant ionic lattice, giant metallic lattice, delocalized electrons. We've got to be really clear it's the ions that are moving in the first case and carrying the charge, and the delocalized electrons that are moving in the second case and carrying the charge there.